Are you able to see? Okay, I think this is okay. So finite automata is represented by FA in short. So finite automata are of two types. One is DFA and another is NFA. NFA stands for and DFA stands for. D stands for deterministic finite automata and N represents non-deterministic. Okay, so finite automata are of two types, which are those DFA and NFA. D stands for deterministic and N stands for non-deterministic. What exactly this means? So in last discussion, we have seen that we are representing finite automata with the help of the representation N, where N is representing machine, and it is represented by 5 tuples Q, alphabet, delta, Q0 and F. So as opposed to the finite state machine, we don't have output in finite automata. Why? Because finite automata is a special kind of finite state machine which is used for recognizing the language, or it is used as language acceptor. So whether the particular string is belonging to a particular language or not, to check it, we are using this finite automata. So how exactly we represent it? Suppose there is a state which is represented as Q0 and next state is suppose Q1, then there is a state Q2. So we have seen the representation. If there are double circle, then that state is a final state, and the state with the arrow is called as initial state or starting state. Okay, so many times the students makes mistakes that they forget this arrow. This is very important. So unless and until we are specifying this arrow, they are starting from Q0, Q1, Q2, but they don't draw this arrow. But this is an indicator of initial state. Okay, and many a times I have cut marks for this representation if the students are not representing it. Okay, so now we are moving. So in last lecture we have seen that Q is representing the set of finite set of states. So Q is representing states. Summation, which is alphabet, is representing what? Input. Then this is representing your STF, state function. Q0 is indicating your initial state and F is representing your final state. Okay, so in this way we are representing any finite automata. Is it clear to everyone? Okay, so now we will try to discuss this finite automata in detail. Now when we are saying that the finite automata are of two types, so what exactly this means? Now as we have discussed, the finite state machine and now the finite automata is represented by a transition graph, right? It's a transition graph. In this transition graph there are states which are represented here by circle, and there is an arrow. It may be a self arrow like this, okay, or it can be any arrow from one state to another state. So when we are representing finite automata with the help of this states and transitions, okay, that time if you will observe this spatial kind, this particular finite automata, what is the observation? Suppose I am writing my this is having, now can I write Q is equal to Q0, Q1 and Q2? From where I have written this Q1, Q2, Q0 from this diagram. Okay. Now what is my alphabet? My alphabet I am considering here suppose 0 and 1. That means my input, finite input set is the what? Having two symbols 0 and 1. So I am now trying to, when you are in initial state Q0, if I give here 0, okay, then it will move to Q1. If I give here again 0, it will move to suppose Q1. If I give here 1, then it is moving to Q2. Okay. So here this 0 is representing my input alphabet symbol, and Q0, Q1, Q2 is representing for this finite automata the set of states. Now what about delta function? So delta function is representing SKF state function. So here we have to write for every pair. Every pair means Q0 into 0, what will be the next state? Q0 into 1, then what will be the state? Or from this diagram, I can draw it. So Q0 on 0 moves to Q1. Now Q0 on 1, there is no indication here. So I did not consider, I can keep it as blank. Are you able to see? Yes. So in this SKF, Q0 into 0, see here, Q0 on 0 moves to Q1. I have represented here, this is my Q into summation is giving you next state. Is it the representation we have discussed in last lecture? So Q into summation gives you Q, right? So similarly, I have replaced this capital Q by Q0 state. My alphabet symbol is now here in this diagram 0. And what is my next state? So Q0 on 0, it is moving to Q1, right? So I have written here Q1. Now Q0 with the input symbol 1, it is not moving anywhere. So I have kept it as dash. Similarly, my next will be what? Q1 into 0. Is there any indication in this diagram? Yes. So Q1 on 0 moves to itself. So my current state is Q1, my input symbol is 0, and my next state will also be Q1. Is it clear? Next, Q1 on 1. Q1 on 1. Is there any indication in this finite automata? Yes. So Q1 on 1, it is moving to state Q2. Is it clear? So I can represent here Q1 into 1 is giving you information, it is moving to Q2. Now we are spatially indicating the final state with the dot. In some literatures, it is also represented by the star. And the initial state like this is represented by this. So as soon as the state with this arrow is appearing, you should understand it is a initial state, and any state with the dot in the right hand side mark, you can consider it as a finite state. Okay. Next, so the turn of this Q0 and Q1 state is over. Is it? Now we have to consider for, is it clear? So turn of Q0 state and Q1 state is over. Now I need to find out about the Q2 state. So I have told you just now, we have to consider combination of each state with every alphabet, and then only we will be able to find out this delta function. Okay. So here Q2 on 0. Now see again this diagram, whether there is any indication in this finite automata that what will happen if you give input to this Q2 state as a 0. Yes, tell me. So there is no any outgoing edge from Q2. Okay. Either for the input symbol 0 or any input symbol 1. Is it? So here I can say that there is no entry for Q2 into 0 is going nowhere. Similarly, Q2 into 1 goes nowhere. Okay. So this is the indication of the third representation. So once I am clear with this, okay, I can easily prepare the delta function. So now, can I say now that my delta function is ready with this all discussion from a given finite automata? So I will draw this now. So my delta function will look like this. So how many rows and how many columns will be there? So this number of rows are representing the states and number of columns are representing my input. Same way we have represented in finite state machine. Here we have written S and here we have written I. Is it? So now very first we will note down all the states. So how many states are there here? Q0, Q1 and Q2. Is it clear? Now there is a special indication to special states where special state is what? Q0 is acting as initial state and Q2 is acting as a final state. Right? So this is clearly indicating in a given finite automata which are the initial and which are the final state. So generally initial state is single state, but there can be multiple final states. Is it clear? Now here summation will be, here I am having summation as 0 and 1. So I am writing here 0 and 1. Now just now we have seen from the given finite automata all these things. I am just putting this value here. What are those values now? I'll make like this rows and now I am filling the values. So Q0 into 0 is giving me Q1. So I am writing Q0 into 0 is moving to next state, that is Q1. Similarly, Q0 with the input 1, it is going nowhere. So I am just marking here dash. Clear? Similarly, Q1 on 0 moves to Q1, self loop. So I am writing here Q1. Q1 on 1 moves to Q2. Right? Now here there is no need to mark it like dot or with star because it is already marked here, which is the indicator of Q2 is a final state. Now third is Q2 into 0, there is a dash, and Q2 into 1 also dash. So I will keep like this only. So in short, I can say that this is my SPF or my delta function for a given finite automata. This was my given finite automata, and for that, now can I say that I have defined the first value, that is Q. Is it? Similarly, have I identified which are the input or defined the alphabet? Yes. Is it? Next, whether I know, so here this is also known now. Whether I am knowing this delta function, just now we have drawn this delta function, right? Now next is the Q0, is it? So here in this finite automata, my Q0 is having same name, that is nothing but Q0, right? My initial state is Q0. And what about my final state? My final state is, are you able to listen me? Okay. Okay, so What is my initial state? Q0. And what about my F? My F for current finite automata, it's is equal to Q2. So once I know all this information, is it? So Q0 and F is also known. So now I can say that I know everything about my finite automata and I can easily represent. So here what we have done, here we have very first drawn the finite automata and we have tried to identify what are the different parameters of the finite automata. I hope this is clear to everyone. Okay. So now the question was, what is the meaning of DFA and what is the meaning of NFA? What is the difference? So difference is, now clearly observe this particular finite automata. Everybody is able to see this finite automata. So this finite automata, is it clearly visible? Okay. Now you have to answer me for every single state and single input where that particular combination is moving. Now, for example, Q0 with input symbol 0, it is moving to a state Q1. Whether there is any more such indications like Q0 on 0 moves to Q2 in this diagram? Are you getting me? So there is no other transition from Q0 on 0 to other state than the Q1. So whenever in any finite automata, we can easily represent it here also. So Q0 on 0 moves to a single state Q1. Is it clear? Similarly, Q1 on 0 moves to a single state. Q1 on 1 moves to single state. So whenever with a current state, with a current input symbol, if you are moving to a single and only one state, then that type of finite automata is called as DFA, deterministic finite automata. So this particular diagram or finite automata is the example of deterministic finite automata. Why? Again repeating, for every current, once again repeating, for every state, for current input symbol, it is only moving to a single state. There is no other transition. Q0 on 0 moves to Q2. So in that case, what will happen? There will be two entries here. Q0 on 0 moves to Q1 as well as Q0 on 0 moves to Q2. In same cell, you can have two entries, right? But here in this figure, for all the states, there is no such case. Every state with single input moving to only single state. And hence, we call such finite automata as deterministic finite automata. Now the question arises, why this is named as deterministic? Because it is determined that if I get a particular input 0 for a current state Q0, to which state I have to move, single and single state. But if there is, suppose one more arrow like this, Q0 to Q2, in that case what will happen? There is a problem, okay, whether it should move from Q0 on 0 to Q1 or Q0 on 0 to Q2. So it is having problem. It is having some possibility of having two paths for 0. Okay. So such confusions are not there in deterministic finite. It is determined that on current input with the current state where exactly to a single state it has to move. That's why such finite automata are called as deterministic finite automata. Now, as opposed to this, the non-deterministic finite automata are the finite automata where you have transition to more than one state for current input symbol and current state. Okay. So if I will try to draw same thing here. So I'm drawing once again. This is my Q0, then Q1, then Q2, right? So now on 0 it is moving to Q1, on 0 it is moving to itself, on 1 it is moving to Q2. So this is a deterministic finite automaton. Now see what I am doing, I am adding one more transition like this. What happened? And I am giving here the input as 0. Now what had happened in this case? The thing is, with the current state Q0, on input symbol 0, okay, it is having two paths, either it can move to Q1 or it can move to Q2, okay. So such a finite automatas where you are having such kind of transitions, that is with the current state, with the current input symbol, you can have multiple transitions, then we call such type of finite automata as non-deterministic finite automata. Now the question arises, so I am explaining you. See here. So once again I will draw same finite automata. It is so DFA. So is it visible? Q0, Q1, Q2, double circle, final state 0, 0, 1, right? Now we want to know what is the language accepted by this finite automata. Okay, how to know this? Now suppose here when I am in initial state, what is necessary to move to Q1 state? It is necessary in my given string there must be a 0. Everybody agree with me? Otherwise, if in a given input no 0 is present, you will never move from Q0 to Q1 state. I'll explain once again. Okay. Next is when you are in Q1, there is a self loop for the 0, right? Now, when self loop is there, it is an optional thing. Why it is optional thing? Because I can now move with Q1 on 0 to Q1. I will remain in Q1. But if I want to reach to final state, this is my final state, right? So if I want to reach final state, what is must? The must is after 0, I must have 1. Okay. So if my input is 0, 1, I can reach from initial state to final state. So in short, I can say that the minimum size string acceptable to this finite automata will be 0, 1. In other words, if I want to show it with the simulation, how I will show you. Now suppose my current state is there, then there is a input and there is a next state. Okay, so this is called as simulation and we should be able to do it. Now my current input is, I am giving input as 0, 1. I am giving input as 0, 1 to this finite automata, and I want to check whether this string is acceptable to this finite automata or not. How I will check? If I can reach from initial state to final state with this input string, then I can say it is acceptable. How I will show it? I will show it like my current state is initially Q0. My input is 0, right? What is my next state? My next state is Q1, right? Next. Now this Q1 is acting as my current state, right? So the term of this 0 is over here, right? Now 1 will come. So now to Q1, you are giving input as 1, this one, right? So what will happen? Q1 with the input 1, it is reaching to final state, right? Now this Q2 is acting as the next state, that is current state. But what happened here? my string is over, and my string was having only two symbols, 0 and 1. And with this combination, I could reach to final state. That's why I can say that my total string is also read. I have read total string 0, 1, and I have also reached to final state. So I am what this particular 0, 1 string is acceptable to my finite automata. Is it clear? So how to check whether the given input is acceptable to given finite automata or not? If you give input and from initial state to final state reading all the symbols in a given string, you are reaching final state, then it is acceptable. Now I ask you, if I give input as 1, 0. Now my input is 1, 0. What will happen? Am I able to reach to final state to the initial state? Now again we will see this finite automata. Here what is happening? When I am going to Q0, there is no path indicated in total finite automata as what? On 1 where it should go. Okay? There is no any transitions available from Q0 for the input 1, right? That's why what happens, as it is shown also in this, Q0 on 1 goes nowhere. So I have stuck up now. I don't have any way to move ahead. There is no way to reach to final state. So there only what will happen, I can easily conclude this particular string is not acceptable to the given finite automata, right? But this is acceptable. So how to check whether the given input is acceptable to the finite automaton? Is it clear? We'll be giving input. Now one more example I am taking. Now suppose I am having 0, 0 and 1. What is your answer? Just tell me the answer. If my string is 0, 0, 1, then this first 0 I am moving to Q1. Then this second 0 I will be in a Q1, right? And then with this one I can reach to Q2, right? So 0, 0, 1 is also acceptable. Now my next question is whether 0, 1, 0, is it acceptable? Is it acceptable? Yes, send me the message. No. What about others? Is it clear why it is no? Okay, so I'll explain why it is not acceptable. So the reason is, now when I am giving input as what? 0, 1, 0. What will happen? With this first 0, I will move to Q1. With this second one, I will move to Q2. Now again, I have not read total string. I have reached final state, but it is also necessary that your complete input string must be read. So since you have not completed reading your total string, so there is no path available after Q2 where to go on Q2 if 0 input is coming. Nowhere, nothing is shown in this diagram, no transitions are there. So you have stuck up by reading only 2 symbols in a given string. Still you are remaining with reading this 0. Okay, so you will say clearly that this particular string is not acceptable. See here, in this also we have shown Q2 on 0, no indication, Q2 on 1, no indication. But your input is available and you have not read it. So you have to give the answer for this input as not acceptable. Is it clear? Now one more question. If I give you the input as 0, 0, 0, 1, will it be acceptable? 0, 0, 0, 1. Will this string will be acceptable? Once again, so I am now writing here 0, 0, 0, 1. Right? So with this first 0 to Q0, it is moving to Q1. Then by reading next 0 on Q1, it is remaining in Q1. So second 0 is also read. Now again it is in Q1 and it is reading 0, right? Third 0. So again after reading 0 at Q1, it will be coming back to Q1, right? Then it is reading to Q1. So when it is reading 1, it will move to Q2, right? So my total string is also read and I have also reached to final state. So finally the conclusion is this is acceptable. Okay. So final answer is this is acceptable. Right? So from all these observations, can you tell me what is the language? So we have seen in the last lecture how we represent a language acceptable by finite automata. It is represented by this capital L in bracket M, where L is representing language and M is representing the machine, finite automata. So we have just drawn this machine. There will be different kinds of machine for different purposes. Okay. So now we want to know what is the purpose of this machine from all this observation. What are your observations? Now see, which are the acceptable strings? This is acceptable, and the very first string, which one? I have written 101. It was also acceptable. Okay, we had now how many examples? 5 examples. Out of 5 examples, we have seen which are the acceptable examples 1, 2, and 3. Right? Everybody agree? There are 3 strings which are acceptable. Right? Which are those? This is first one, this is second one, and this is the third one. Now from these 3 strings, what are your observation about language? Language in the sense, what will be a set which you can represent here from this observation? What are the common things in these 3 strings? Can you observe anything from this? Any observations? Any similarity between these 3 strings? So if you will find, the similarity is every string is starting with 0, right? And second similarity is every string is ending with 1, right? Everybody agree? And in other cases where it is not acceptable, this is not satisfying. In this case, its starting is not satisfying, right? In this case, its starting is satisfying, but its ending is not satisfying. That's why these 2 cases are cancelled. They are not acceptable. So from this, can I write these 3 examples at least? So 0, 1 is acceptable, 0, 0, 1 is acceptable, and 0, 0, 0, 1 is acceptable. Now the question, is it? I have written the language acceptable by this machine will be having which strings? 0, 1, 0, 0, 1, 0, 0, 0, 1. Can I have this as an infinite set? Yes. Why we can have this as an infinite set? You can observe here. Here there in a single minimum size string acceptable by this finite automata was 0, 1. Next size. So it is having what size of string? 2. Length of this string is 2. Here the length is 3. Here the length is 4. Now, may I ask you one more question, whether string 0, 0, 0, 0, 1 will be acceptable? Now here there were two zeros in between, and here you are having three zeros in between. Okay, so like this, if I change number of zeros in between 0 and 1, then I can say that my string will be acceptable. So I can have any number of zeros in the center, okay, where it is necessary my starting should be 0 and my ending should be 1, right? So like this, there can be any strings generated. Like I can have 0, 1, 0, 0, 1, 0, 0, 0, 1. Now I can have any size. Here the size of this string is 5. So I can have any size of string which can be part of this language, right? So my language which is acceptable by this finite automata will be this one. And how I will represent this language? So I can say that the language acceptable by this language is language acceptable by above FA is having starting symbol as 0 and ending symbol as 1. Okay, so we are only talking about starting and ending symbol. Now whether there is any more restrictions, can I have only with this the correct definition of my language? No, because if I am only saying 0 starting with 0 and ending with 1, so I can have in between 1 also, that is also description of this language. So it is not correct, total correct description of my language. So I need to add one more information to describe my language which is acceptable by finite automata. What it will be? So the language acceptable by above finite automata is having starting symbol as 0 and having starting symbol as 0 and ending symbol as 1, and it can have any number of zero in middle, right? So you can have again a proper language for description of this language which is acceptable. So now if I represent my finite automata which is accepting a language which is representing here, so I can say that I have designed a finite automata which is accepting a language which is having strings starting with 0 and ending with 1. Other strings will not be acceptable by finite automata. Okay, so finally we can conclude that the finite automata is now acting as a language acceptor. How? If I give any input string to it, it can tell me whether the given input string is acceptable by that finite automata for which language it is defined. So what language? How you will write? The language defined here was what? It is a finite, it is a language which is having all the strings which is starting with 0 and ending with 1, where there can be any number of zeros in it. Okay. Apart from such strings, no other strings will be part of this language. So in short, if I want to correlate it, I can say that all these are the valid words of the language. Okay, just like we can have any combination of alphabets in English. Just like I've given you the example, A-R-E-R is a valid spelling. So it will be a part of a language. But if I write R-A-E, so this is not, this is also a combination of different alphabets, but it is not a valid word of English. Okay, so it will not be a part of that language. Similarly, the part of this language will be having only such a type of strings. So I hope you have understood how the finite automata is represented. What do you mean by deterministic finite automata? What do you mean by non-deterministic finite automata? Okay, and how to represent the finite automata with the 5 tuples.